I, Gunwan Patil, here to present the solution in the Smart India Hackthon 2023. Let me tell you how significant our problem is. Growing certain plants in remote areas such as desert and in North Pole and the South Pole can be challenged because of the extreme outside weather. Very few species of the plants thrive in such a situation and are often not used as the food source. So we came with the solution that develop an efficient and cost-effective hydroponic system that addresses the challenges of sustainable urban agriculture, including limited space, resource conservation, and consistent crop production to enable year-round cultivation of high-quality vegetables and the herbs in the urban setting. And we are going to create a system that can grow common plants and the vegetables and can operate without depending on the outside climate. We achieve by this using a technique called hydroponic system. Hydroponic system is a method of growing plant without using the soil. The system was automated using the microcontrollers and the sensors to keep the human intervention at the minimum. And Internet of the Things, that's the IoT network, was created to improve the reliability and remote the monitoring of the control if needed. The user is only required to plant and set the initial parameters. Once done, the system is able to maintain the parameters and promote healthy plant growth. The goal of the project is to make a system is cost effective and most importantly is completely automated and requires virtually no human interaction after placing the germinated plant into the system. The other expects to create a system that can be used by the typical consumer, meaning that is relatively small and simple to use. Now we are discuss the designing of the hydroponic system parameters. First one, there is a hydroponic setup in which we are going to utilize a controlled environment with trays or containers for growing the plants. Implement a recirculating nutrition solution system to deliver the essential nutrition to the plants. Then nutrition solution. It is a mix of balanced and nutrient solution with essential elements required for the plant growth, ensuring the proper pH levels. Then the growing medium, in which we are going to use an inert growing medium like perlite, coconut coir or rock wool to provide and support the aeration for the plants. Then the lighting. Integrate LED grow lights with adjustable intensity to mimic natural sunlight for the optimum. Another consideration is the automation and monitoring, in which we are going to implement a sensor for monitoring the nutrition level, pH level, temperature and the humidity. Automated nutrition dosing and irrigation based on the sensor data to optimize the plant growth. An important concern is about the water management. Collect and filter the water to ensure that its purity before the circulating in the system. Use a reservoir to store and manage the nutrition solution. Another main aspect is about the plant care and the maintenance. Regularly inspect and maintain the system, ensuring it remains free of the pests and disease. Monitor the plant growth and adjust the nutrition level accordingly. Then scaling and expansion. Design the system to be modular, allowing for the easy expansion as the farm grows. Optimize space usage for the maximum crop yield per square foot. And last, that is the data analysis and the optimization. We are going to collect and analyze the data over a time to optimize nutrition formulation, lighting schedule and growth condition. Create a successful hydroponic farming system. We have to need essential components and dependencies that contribute to the efficiency and the productivity. And now we are going to discuss about the key components as considered as the showstoppers for the hydroponic system. This is our architectural diagram, in which we are going to provide a detailed explanation of each component. However, the specific home use improvements include the additional home IoT devices to gather user activity logs and web API to gather the weather information. The system monitor logic is self-adaptive and human-centered. Its overall behavior is controlled using a monitor analyzer plan execute over a shared knowledge of the base loop, a general mechanism commonly used to design an architectural building block in autonomic computing. The system going to use two Arduino boards for analysis of the resource data and the control. A Raspberry Pi is used to run automation software. Once the Raspberry Pi receives the input data, it updates to the server. The system also uses a mobile app to enable monitoring and control from the iOS or Android devices. Because the system is relatively small, smaller than a mini refrigerator, it can fit into small OFP space or a loop in the home. This accomplishes the second goal of the project, the complete automation and the size are what make our project different from the other hydroponic